In this video, we will discuss data path for single cycle instruction, and this video is specifically for our type of instruction. We will discuss about load word, stored word, then jump kind of instruction in next videos. Let's just assume that we have an instruction which is of our type: add $T0, $T1, $S2. Now we know that in MIPS we have 32 bits of instruction. These 32 bits are divided as 6 bits are reserved for functions, next 5 bits are reserved for shift amount. These 5 bits represent RD, these 5 bits represent RT, and this 5 bits represents RS. The next 6 bits tells you about the opcode of the instruction. We can also divide this using bit range, which is 0 to 5, which is for function. Next 6 to 10 is for shift amount. Then 11 to 15 is for RD. Then 16 to 20 is RT. 21 to 25 is RS. And then 26 to 31 is for opcode. Now let's discuss the data path for our type of instruction. First of all, the program counter. This is program counter. This will tell you about the address of the instruction that you want to execute. This is instruction memory. You have to tell the address to instruction memory and it will fetch out the instruction for you. Then we have register file, which can tell you about the data of register if you provide the address to these registers. And then we have ALU, which is arithmetic logical operation performer. This can perform simple arithmetical or logical operations like plus, minus, multiply, subtract, these kind of operations. Now first of all, the program counter fetch the address of the instruction that you want to execute. This address through the instruction memory gets you to the instruction. The instruction is then divided into 3 parts. We have discussed these division earlier in the video. Now RS, RT and RD. This RS and RT gives you the address of these registers, these 2 registers, to read the data. And the third one, which is RD, which is destination register, it gets you the address of the register which you want to write. For example, the add instruction we have discussed. The add instruction tells you it has 3 operands, 1, 3, 4. This instruction add these 2 and place them here. So we would have to perform some operation to these 2, which means we have to pass them to ALU. So this RS and RT is passed on to get the data of the register, read address, and then read data on these address. Read address 2 and read data of the register 2. These 2 are passed on to ALU, which then gets you the result here. The data that you want to write is passed on here. The address has been fetched on by this register earlier, so it will write out that data here. Now program counter wants to increment to next instruction, so we are putting an adder here. It will add 4, and the address of next instruction is been placed in PC. This 4 means that you want to add 4 bytes in program counter. Thank you.